Обычно я начинаю этот доклад со слов на родном языке и очень сильно извиняюсь, что я на родном для слушателей языке, и очень сильно извиняюсь, что я плохо говорю на нем, потому что обычно это происходит на французском. Сегодня, слава богу, значительно проще говорить на русском, но, к сожалению, для вас Николя не так хорош в русском, поэтому мы переключимся на английский.
Я не понимаю ничего.
So, let me introduce Nicolas Fränkel.
Yeah, thank you, Evgeny. Welcome to this talk about mutation testing. First, I must say that you are very courageous to be there instead of being in the main room with the big guy. So thanks just for that. We will try to make this talk as interesting as possible for you to reward you.
Sorry, Nicolas. In fact, if you would like, you can stand up and leave the room. And I will join you because I would like to hear Alexei.
So I'm Nicolas Fränkel. I've been there only once already. I'm either a developer or an architect, depends on the exact organization. I'm also a teacher and a trainer. I'm a book author. I'm a blogger. I work for a company called Hybris, who provides a platform based on Spring and Java to provide e-commerce features. And now, this is Evgeny Mandrikov.
Okay, you know, as usual, any superhero, even such a superhero as Nicola, who is a teacher, book author, and so on, any superhero needs an antipode. So today I'm going to play a role of antipode, the devil's advocate for this guy. My name is, as was said, Evgeny Mandrikov. I'm a technical leader at Sonar Source. We are developing a product for static source analysis.
Who knows about Sonar Source?
No? Ooh.
Who uses Sonar Cube?
Pretty cool.
Yeah, that's good.
Okay.
So this half of the room should definitely use it.
But no worries, this talk is not going to be about Sonar Cube and Sonar Source.
Okay, thanks. So, as you know, there are many kinds of testing. And most probably you've heard about unit testing, because unit testing is everywhere. Now, if you, as a developer, you don't test your code, you will be like excluded from the developer club. You also have integration testing. You have performance testing, you have security testing, penetration testing, exploratory testing. You have many, many kinds of testing. But in what you do, all this testing only has a single target. It is to prove that your production code is good enough. So everything is aimed at the production code, and it makes sense, right? However, you leave something very important aside. Say, how can you check that your tests are good enough, that your tests are relevant? Okay?
Okay, come on, Nicola. I'm pretty sure everybody knows how to check the quality of the test.
Sure, everybody bitches about
ask.
It. You're right, you're right. Yeah, code coverage. Code coverage is the way to check your tests are relevant, you know? And you can measure it, you can have nice metrics, and yeah, keep the bar green to keep the code clean. And in this case, it's not about the test that passes, but you have 100% code coverage.
Can we check how many people are using computing code coverage? Okay.
Okay, this is your main metric to follow the quality. Okay, makes sense. So how do you measure it? Very simply, you execute the tests, and then you check line by line if the line was executed or not. And you can do the same with branches. And then you've got branch coverage. So it's very simple. And then even me, I'm not a mathematician, you know, I count the number of executed lines, and I divide by the number of total lines, and I multiply by 100, and it gives me a very simple metric, percentage of code coverage. And you've got many tools in Java to do code coverage. There is, of course, Jacoco.
You probably changed it in order. Jacoco was the last one.
Okay. Jacoco is made by Evgeny, so that's why I'm telling you that. Before that, you had Clover, which was a paid tool. You've got Kobotura. Yeah, we've got tooling to do that. So why don't we use it? And of course, some people, very famous, renowned people, say 100% code coverage. Of course, if you can write a line of code, you can test it. So your goal is to achieve 100% test coverage.
But let's check also what's the goal for people there. Who is targeting, I don't know, 30% of code coverage on their projects? More?
Who has no target at all?
80.
80 is quite good.
80, okay. Someone more? 90? Okay, cool. Even more? 100? No? Okay. Below 80? Okay. How you choose that value? How you choose that for you a target is 80 or 70 or whatever? Random. Okay.
Yeah.
But you shouldn't. The ultimate goal is 100% coverage. That's it. You go for it. That's the rule. All other values, it's bullshit.
You write a line of code, you can test it. He says it. Who knows Robert Martin? Yeah, he's very famous.
Very
he's
famous guy. 100% coverage. The only goal. That's it.
Yeah, you should follow his rules. And now I present you a code that has 100% code coverage. So I've created a math class which adds a method. Of course, it's stupid because Java has it. And if I execute this test, I will have 100% code coverage. Oh, but I just forgot the assert. But I don't care. My metric is code coverage. I've got 100%. Who said anything about assertions? So I have the best code coverage of all of you. I have 100%. No, really. So if you take code coverage as your measure of code quality, you are making a very, very big mistake because any metric can be gained. And code coverage is, as I've showed you, an easy metric to gain. And you can do it on purpose, or you can, forget just about some assertions and still execute the code and still have 100% code coverage. And it's much worse, because when you have nothing, you know, when you go to a project and you have no tests at all, you are very cautious. But then you go to a project and the guys are bragging about 100% test coverage. You change stuff. You run your tests again, 100% again. Yeah, let's put it to production. Yeah. So it's worse having 100% test coverage, as I've shown you, than having nothing. Okay? Did I make my point? That's good.
Do you have a solution for that?
Yeah. So that's the problem. If we cannot rely on code coverage, what can we rely on? And of course, there is something very new. No, it's very old. A technique called mutation testing. Okay, so mutation testing goes like that. Who knows about the X-Men movie? Yeah, sure, great. Me too. So that's very easy, even for me to understand. So in the movie, he's a bad guy, William Stryker. But in this case, it will be my original source code. Okay? And then his son will be Jason Stryker, the mutant. You know, I don't know if he's a bad guy in the movie, but anyway.
He is.
Okay. And it will be the modified source code. So mutation testing goes like this. I will have my math class that I want to test, and I will create a mutant out of it. And notice that I'm updating the production code. So here in my original code, I have a plus. In my mutate, I have a minus. So I take nearly the same code, but I just change a little bit. So with standard testing, it goes like this. I execute my test. I've got it green. I'm very happy. With mutation testing, what I will do is I will create a mutation. And I will execute the same test, exactly the same test. And then I have two options. Either it fails, and it makes sense, because if I change my original code and I execute the same test, it should fail. And yes, I can have another option. If it's green, then something is very fishy. So in the first case, we say that the mutant has been killed. And in the second case, we say that the mutant survived. So it's not like in the movie. We should kill the mutants, okay? So we should kill the mutants. So again, surviving means changing the source code did not change the result, and it's bad. And killed means changing the source code changed the result, it's good. Okay? Are you following me at this point? Great. Okay, so that is my initial example without the asserts. When I execute it, of course, it's like in my previous snippet, it works fine. I've got green result. Now, if I replace the plus by a minus and I execute the test, since I have no assert, it's still green, so it's bad. Now, if I add an assert here and I execute this test, of course, it's green because I'm expecting 2. But then if I replace by a minus and I execute the same test, it fails. So it's good. So those are the simple basics of mutation testing. And anyone can understand that. Even I. So how do we achieve that in Java? The good thing is that in Java, we already have the tooling for that. There is a tool called Pit, and it's available. Who uses Maven? Yeah, nearly everyone, that's good. Who is old enough to still use Ant? Sorry about you guys. Who is hype and uses Gradle?
Sorry.
No, come on, no, not you. Okay, anyway, whatever you use, you can use Pit as a command line tool. You can use an on-target, you can have a Maven plugin. And probably, if you want, you can probably create your Gradle plugin by wrapping the command line. So it's quite easy. How does Pit work? Basically, you have mutators. And mutators are patterns that are applied to your source code. So for example, there is a Pit mutator called conditional boundary. Conditional boundary will replace, and I will try to make this. Yeah, it works. The higher by higher or equals. Okay? So it will replace your source code like that and execute the same test.
Can it replace less than by less than equal?
That's a very good question. Thanks, Evgeny. Who is following? Come on, it doesn't have to we just did it before. If nobody asks the question, he will do it, but please, you can ask questions. Okay, of course, it's also possible to replace lower than by lower or equals, or it's also possible to replace lower or equals by just lower than. It's just a specific pattern. Okay, it will try to revert the conditionals. It will remove them at all. It will, as we have seen, replace plus by minus, multiply by divide, and so on and so forth. It will change the increments, invert the negatives, and many, many different things. So basically, you have those mutators. And of course, you can create your own, because it's very simple. I think there are two very important mutators in Pit, because those are the most probable causes for bugs. The first is the conditional boundary. Generally speaking, what you are doing when you are testing code with a conditional boundary is you are testing above the boundary and below, but most of the cases, most of the times, you don't test when it's equal. And this is a very, very huge source of bugs. The second important mutator is when you have void method calls. Void method calls probably create just side effects. They don't return values. So those are just about side effects. And what happened is probably you want to check that a value is not null or that you close your connection. In general, this is not tested because it's hard to test. But it's not because it's hard to test that you shouldn't test it. And what happens is that, yeah, everybody knows that there is an assert that this parameter is not null, and it's not tested, and then someone has a need to pass a null parameter for whatever reason. And it changes it in the production code, and then execute the test. Still, everything is green, push to production, big issue. So those are the most important mutators in my opinion. Also, what you want to test, and that you probably never do, is equals and hash code. Why? Because they are generated by the IDE. And the IDE is not wrong, and it's true. The problem is that what the IDE generates at time t will probably need to be updated afterwards. And it will probably be done manually. And then you introduce bugs. Of course, you can have false positives. I'm sorry. It's not 100% bulletproof. So again, it's not about the metric, it's what you want to achieve by the metric. So you have to be wary about that. So,
Nicolas, it has been quite a good time, but I'm starting to be sleepy like our colleagues, so...
Who is sleepy?
Enough blah, blah, blah. Can we start a demo?
Okay, yeah, let's do a demo. You're right. Okay, so let's do a small demo. Here, I've created a math class, just like I showed you. Nothing mind-blowing, okay? And because I know that in the GDK there is already a math class, I called it duplicate math. And, yeah. And then, I want to show you that I can forget about the equals, okay? And I will run the tests. Oh, and this is small. Bigger. Bigger?
Do you know how to use keyboard shortcuts?
Yeah, sorry about this, because I have an external keyboard because my laptop keyboard is dead. So, lesson for you, if you remember something from this talk, is Coq Zero and laptops don't go well together. Anyway, I will just... So I will just run the test like that. And believe me that there is Maven underneath. And though it does its tests. And we will check the results. And now, if I go on my reports, here, and now, yes, that's easier. Oh, what did I go wrong? Something I did wrong. Sorry about that. I will clean again, because normally you should be mind blown. Hey, that's the demo syndrome, guys.
And does we have a JetBrains plugin?
Ah, that's a good question, actually.
I don't think so.
Yeah, they have.
Whoa, that's awkward, guys. Okay, so I will do it again, but now I will start from scratch because I don't know why, but here I got 100% code coverage, which is good. No, it's not the good one. That's why, and nobody is following here. Yes, much better, thanks. So, here, I'm very proud because, as I showed you before, I have 100% code coverage. So I can do anything on this code, and yeah, I will always have 100%. But Pete is smart enough to tell you, hey guy, you forgot, you've got 0% mutation coverage, which means that your test code is crappy as hell. And why? So, he applied 2 mutators, but the first one is enough, and he replaced addition with subtraction. And by replacing addition with subtraction, he ran the same test, and then he got a success. So the mutant survived, which is bad. Now, if I try to kill the mutant by being a good developer and adding equals, asserts in my code, and I rerun it again, and perhaps you have the joke meanwhile.
No.
No joke?
I wanted to ask to keep clean. You know, you forget it before, but...
Okay, and now that's good because everything is green. It killed all my mutants. And if I reload, I have 100% mutation coverage. And now I am sure, at least nearly sure, that my testing code is bulletproof. And that is very important.
Sorry, Nicola, I'm still falling into sleep because, come on, it's not at all a representative example. You've wrote, I don't know, one line of code, you've wrote a test for it, you forget assertion.
Who wants another
it's not
demo?
realistic.
Who wants another?
Nicola, please, show something real. I'm pretty sure you can do that.
Okay. So, that's good that I prepared because you took me... Okay, this is something, a mathematical function. Basically, it filters. If the filter is below the limit, it will return true. If it's above or equals, it will return false. Simple stuff. And this time, I won't try to game the system. I will create the tests and I will test really what I want. Okay? So I try to test below, and I try to test above. And this makes sense. This is exactly what I would write in a normal project. And then I will rerun it again. And I clean just to be sure. Still no jokes?
Don't forget to open correct report.
Yes. Okay. Yes, it's better if you open the correct one. So here, I still have 100% because I tested above and I tested below. So even my branch coverage has 100%. But Pit still tells me that something is fishy. And here, why? Yeah, because it changed the conditional boundary, meaning it replaced the lower equals by lower, by lower or equals. And my test suite didn't change the result. I forgot to test the boundary itself. So let's do that. And now, if I rerun the stuff, and I check again, I killed everything. And that is something that every one of you, including me, does all the time. We forgot to test at the boundary. Who doesn't forget that? And now everyone ends up and then, oh no.
Why you even asked?
Yeah, no. Even you can make mistakes, you can have junior developers, you do want to test the boundaries. No, you don't agree? No?
But okay, Nikolai.
Okay.
It was again nice. You showed that one more example of, I don't know, 5 lines of code. Do you have something more real? Some real life project, you know?
No, I think it's your time to talk. Oh, perhaps.
No, you don't want to show something
okay.
like, I don't know.
Okay. Who knows about Joda time? Okay, everyone. Who knows about Joda money? Okay.
But so, come on, money is more important than time, you know?
So the good thing is that Joda money is about money, what Joda time is about time. Yeah, makes sense, right? So what we will do is I took the Joda money project from GitHub, and I will try to do mutation testing on it.
Did you try it before? Just to be sure.
Yeah, yeah, I tried it before. So let's do that. So I'm just copy pasting because it's easier. And so it will try to run the stuff. And that's real life problem. It seemed that, I don't know why, but though everything works perfectly when you do MVN test, when you try to apply the Pit plugin, it fails on some classes. It's not good. So what I will do right now is that I will try to exclude those classes. And since I don't know them, but I prepared, I know them already. So I take a project, it can be yours, and I apply mutation testing in one line of plugin. Of course, meanwhile, I don't need a joke, a single one, but I need many jokes because it takes some time, right?
How long is it's gonna take?
And that's the problem. It really depends on your initial number of tests. And it depends on the size of your initial project. But it's good because then you can go take a coffee, or we are in Russia, so we can take a tea.
I'm already falling asleep and you're asking me to wait, how many, half of an hour?
Does Pit test applies all mutations of each type?
Sorry, excuse me?
Does Pit applies all mutations to all types of mutation for each line?
Yeah, that's a problem. We will go back.
Configurable?
Yes, but don't try to, we keep our secret until sometime because don't try to get in advance.
It's open source, which secrets you're talking about? But it's done. How long it took?
So, yeah, that's a good question, Evgeny.
1 minute.
1 minute nearly. That's quite massive, right? So Yoda money. And here I've got my target, and my Pit report is here. And that's interesting because, you know, they are not so bad, actually. They are really not so bad. We can see that we are in one of the package, we nearly have 100% line coverage, but yeah, we only have below 80% of mutation coverage. And in the first package, it's even worse, but even the line coverage is bad. So you can look around and on your own project do it like, oh, here I have 100%, I have 100%. That's quite good. Here I have 100%. Oh, I have 83%. Huh. And here probably lies a bug. And we can check. And at the end, you can check which mutant survived. Here, it said that in this method, the set local was never tested. Interesting. That means that probably there are many test cases missing. And if you don't test it, you can be sure that at some point it will get modified, and then you will still have 100%, and then you will have a bug in production. And now perhaps, so at this point, I guess that I have shown beyond any doubts that code coverage is the best thing since sliced bread, and you should probably use it right now.
Yeah, of course, we should. You showed perfect examples. But,
Thanks.
Nicola, you know, in reality, things are a little bit more complex. In fact, Pit is not a perfect tool. It does mistakes. For example, you could have defensive style of programming. I don't know, you first check that value is less than 0, you throw an exception, or you do whatever, and then you check that value is greater than, and you do some other stuff. And by default, okay, if it is 0, you return 0, that's it. What Pit could potentially do, it could change conditional boundary in a second case from greater than on less than, and it's gonna report that this mutation survived, just because there is exactly the same check, just few lines above. Not very good, don't you find so?
Yeah, I must admit that's not very cool. But perhaps you shouldn't use this kind of code.
Why? Why?
I'm trying, guys, I'm trying.
Okay. Another example. Again, Pit is imperfect. Imagine that you have a code, unsecure code, let's say, such as, I don't know, we are a rebooting machine, which is not really a realistic example, but we could imagine. Or more realistic example, I don't know, you're doing something like rmrf slash plus some pass. And by some coincidence, Pit decides to remove this plus pass. So you're going to do rmrf slash. Oops. In this example, we do check user permissions. Your unit test might cover the case of wrong permissions. But Pit could decide to remove this method call, and during execution of your tests, bam, you're going to reboot machine. Not very good. Be aware of that. Probably in this case, Nicolas, you're right. It's probably not the best practice to write code like this, but who knows? Pit doesn't help with isolation of your code, so from such cases, you better isolate on OS level, or I don't know, to use Docker containers, which are quite popular nowadays, or whatever. What about time? Hold on. Hold on. So, as we just saw, execution on Jodamani, it took something like 1 minute. Nicolas didn't show what the actual test execution on Jodamani takes, but I suppose less than a minute. I tried some real life example.
I can do it right now.
No.
No. Okay. I can do it in background.
He wants, he does. I took some real life example. Of course, it's not a fair play, because I took some commercial product developed by me, so you won't be able to redo the measurements or check what the code base is. But for me, this is quite a representative project. It's my day-to-day job, so I could make some conclusions out of it. So I took a part of Sonar Source frontend for analysis of C++. It has quite, let's say, big or medium code base. It's 15 key lines of code, and about 1K tests in approximately the same amount of lines of code. What is notable that MVN test, just execution of those tests, is quite fast, excluding compilation and so on. It's just 11 seconds. Of course, it was measured with a wall clock time. If this guy would be in this room, he would probably kill me, but thanks God, he's doing presentation. But believe me, this measurement is quite stable. I mean, I do 5 runs, it's 11, 12 seconds over the runs on the same machine. Pit. Oops. Did you remove it some slide? No?
Perhaps.
Thank you, Nicolas. Thank you, Nicolas.
And it was a test to see if you really were going to be able to talk.
I do remember number.
Sorry about that.
But okay, forget. I can tell the number, people would believe me.
And they will be even more amazed.
Yeah. I'm not sure. Okay, if I will do the same code base with Pit, it's gonna take something like 5 minutes, if I'm not mistaken, which is quite long. I mean, we went from 11 seconds to 5 minutes. If I would like to run the same during each commit, it's not gonna be possible. I don't want to wait 5 minutes. I don't know, I will be drinking too much coffee then. So, why it is so slow? Probably because for each class under tests, for each mutator, we need to perform mutation. And for each mutation, we need to run tests, analyze the result, aggregate the result. Even if we assume that creation of mutant, analysis of results, aggregation of results takes 0 time, we need to run the tests multiplied by number of mutations. You have 100 mutations, you multiply, I don't know, by 11 seconds to run your tests, you're going to receive already some minutes. So, this is not acceptable. Can you help me? Is there workarounds? You're the hero, you know, you should help.
Yeah, of course. That's the real problem of mutation testing, is that, of course, it takes time. It takes a shitload of time. And it's not acceptable to wait for so much time when you are running your MVN test, because you want your feedback as soon as possible. So how can you have workarounds? Easy. Who was a multi-core machine? No one? Oh, come on, it's Russia, but still.
Sorry. Sorry, Nicola. Let's put it differently. Who does not? Okay? You need to learn how to ask questions right.
Sorry.
Okay?
They were just sleepy. Okay, you just increase the number of threads and hope that your unit tests are really well isolated.
Yeah.
Which should be the case for unit tests.
Yeah. So for exactly the same code base, I redid the tests with 4 threads, which is equal to the number of physical CPUs on my laptops, and it went down to 1 minute 53 seconds.
Excuse me, I still don't get how does it really help, because if you have in one method a few points for mutation, say not one constant, but 10 constants, you get exponential growth, you can't get exponential forward on your server.
You're right, and please don't break the talk. We didn't stop on that, okay? We're gonna continue, and there will be dedicated time for questions. You know, this is one of the ways, one of many ways to speed up the process. So, I mean, if on your code base all the mutations, as on my code base, they take 5 minutes, this is a good and a cheap way to decrease 5 minutes down to, I don't know, 2 minutes. It's already gives me, I don't know, some speed up.
And zero headache.
Zero headache. It's, I don't know, 1 line of modification in pom.xml. Okay. Is there other ways? Okay, that was the question.
Yeah, I hope so, because the gentleman just is not happy with that. Then, if you want to decrease further, you can easily reduce the number of mutators. You can configure the mutators you will apply. So you can say, okay, I told you basically that 2 mutators were very important to me. You can just apply them. And then you run your test again. And of course, since you reduce the number of mutators, reduce the number of mutations, you reduce the number of executed tests, and it goes much faster.
I'm expecting a question here, and a question in the form like, yeah, but then you are actually reducing quality of mutation testing because you're starting missing cases.
Yeah, but
blah, blah, blah.
It will wait a little till the end of the talk.
Okay. Can we do something else?
Yeah, as Evgeny showed you, sometimes applying mutation testing might just be wrong, because you will just remove everything from your hard drive, or you will reboot your computer. So you might want to apply mutation testing to the most critical part of your code, or to the part which is not under, when you remove a line, can be very serious to your system. So you can remove just some target classes, or in this case, just tell which target classes you want to mutation test. Just like for any test, you try first to put the most important part of your code base on the test. So you can do the same with mutation testing, right?
Yeah. What else?
Okay. You can also decide not to focus on your production code, but to focus on your test code and say, okay, I will only pass those tests with mutation testing. Also works. In the same way, focus on your critical code first. Then there is also another possibility which is offered by PIT. It's about the dependency distance. For example, let's say that my test uses directly a class. This class will be mutated. Give me the red stuff so I don't stand in front of the thing. Okay, so here, if I use a dependency, this one will be mutated, right? But if I use another class which depends on another class, this class will also be mutated. And any fool can see there is something which is called a distance. So here we have a distance of 1, and here we have a distance of 2, because we must make 1 and 2. And this can be configured in PIT so that you can configure a max dependency distance. So production code, which is too far away from your test class, won't be mutated. And it's quite easy, right? Yes?
Question. Does PIT applies only one mutation or one dependency at one time?
Yeah, at one time, yeah. Yeah, because really we want to be sure that this is the reason why the test still was successful.
At a time means during a test execution. Of course, it can apply 100 of mutations per class.
For each test?
Yeah.
And for one test?
Yeah.
Yeah, what if we have runtime dependency? For example, we use inversion control container and we inject dependencies into the runtime. Are there ways to check dependencies?
Yeah, this is the same system. It's just I'm dependent, there is a distance of 1, and if the independency you injected was itself injected, you've got the same chain. Sorry? Yeah.
But it's not going to mutate the dependencies. It's going to mutate your main code, if that was the question.
Do you parse bytecode or do you work with sources?
Do you? We are not the afters of PIT. PIT uses ISM library, so it works on a bytecode. It mutates bytecode. And here I would have an interesting question for you probably, but for you, I mean for you afterwards, yeah. Once again, we will have question answers time, so maybe we should move forward.
Okay, so you can also limit the number of mutations, right? Something which is very, very serious is, as I have shown you, or perhaps it was too small and only the purple in the front row checked it, but when I did the stuff on my own codes, I only typed MVN tests, meaning I bound PIT to the test phase, which is the worst that you can do, because that means that each time you will want to have your unit test results, you will execute PIT, which is a very, very big mistake to make. I want PIT to be decoupled, so that you should never do. Of course, you can configure PIT in your POM, but you don't bind to the test phase. And last but not least,
yeah. Maybe you're going to learn something new today.
Thanks.
As any superhero should do. In fact, Nicolas showed a nice ways to cut something, to reduce the search scope for mutation testing, but it reduces the scope and it doesn't really help much. In terms of time, okay, we cut it by a factor of 2, but not lower. In fact, for a quite long time, there is ability to execute incremental analysis. You execute mutation testing once, you store some data, some metadata, then during each following run, PIT is going to decide what to do. obviously, we don't need to rerun some mutations and some tests if there is no changes in tests and in mutations. We just could skip such combination. So Pete is gonna use, again, dependency analysis, bytecode analysis to determine what was changed and what needs to be executed. Of course, this probably gonna miss reflection because reflection is tricky. Could you switch slide? Yeah, thank you. So, incremental analysis, pretty easy to configure again, not so much headaches, just, I don't know, 6 lines in your pom.xml to preserve the Pit history. Exactly the same execution. So if exactly the same project, execution of Pit tests, if I don't do any changes, it takes, instead of minutes, it takes some seconds just to read the history, determine there is no changes and so on. Then Pete actually showed me one place where I do see unused method call. It shows survived mutant, removal of void method call. So I did remove this unused method call, rerun Pit. It took just 47 seconds. So just to apply mutations on what I modified and to rerun tests against what I modified, which is much better than before.
Sure. Also, you can, and I must admit I never used it, but you can use another target, which is SCM mutation coverage. So normally you use mutation coverage, and you can use SCM mutation coverage. In this case, Pit doesn't look at its analysis file, but look dependent on your SCM, on your SCM files to check if anything changed between the master and your current stuff. What I recommend anyway is you forget about all those stuff that we just told you about the way to reduce the time. Because as Evgeny mentioned, each time you reduce the scope, then you also reduce the safety net. What you want is to be sure that your testing code is good. And of course, you don't want to increase the time. You want to use mutation coverage to ensure that your test code is of high quality. So forget about all of this and do run those stuff on continuous integration server. And you don't care about the time. If it takes 8 hours, you don't care.
You're going to be sleeping at home during those 8 hours during nights.
Hopefully.
Or drink coffee, okay, as you prefer.
Yeah, coffee was the nice version. So, is mutation testing the silver bullet in this case? Yeah, I must say that, yeah, it
is not.
No, it's not. It will check the relevance of your unit test and points out potential bugs that probably you generally detect only when in production. But you still need other kind of testing. So you will still need to validate that the assembled application runs correctly, and this is achieved by integration testing. You will still need performance testing. You will still need end-to-end testing, and all this stuff. So mutation testing won't replace what you are currently doing. It's just an additional tool to make your unit testing more relevant. And you should never forget that testing is about return over investment. Don't listen to people that tell you that only you can have 100% code coverage. You know, they don't work in the real world anymore, you know. They are gurus, they earn a shitload of money that we will never reach, but they are completely, no, I wouldn't say useless, but they are very theoretical. And they are very dogmatic. And we are software engineers. We work with real-life projects. We work with budgets. We work with customers.
You mean with Java time? Java money. It's budgets. Yeah.
So don't aim for 100%. Okay? You test because in the long run, you know that If you don't test, it will cost you money. It's about technical debt. Okay? But you have to find your own metric. And you have to prioritize. I already focused on it. But first, you should test business critical and complex code. This is the most important stuff that you should do first. And the rest is nice to have. Now might be the time for some questions. Thanks for your attention.
Yeah.
Thank you, gentlemen.
I do have, excuse me, I do have some, I don't know what is...
Tokens.
Tokens, yeah, I could give you, and I do have some tricky questions. Could you please scroll on a slide where you show mutations?
Which one?
The table with possible mutations.
Sure. This one?
So, no.
No.
Okay.
I did it. I didn't remove the slide.
Hide this slide.
Okay, I hide this slide. Oh, it's hidden.
So, we know Pit works on a bytecode. Pit has mutations affecting mathematical operations, like +5, I don't know, +42, blah, blah, blah. Which other operation would be affected by mathematical mutator? Sorry, could you? What's the connection? It's boundary mutators.
Maybe it means remove non-using method call.
No, there is another mutator, non-void method calls.
Or string concatenation.
Nope, because string concatenation is not a mass operation.
Things can move to the true, that's true.
No.
Not, or even
Okay, show the slide back.
You ask two hard questions.
It is on the slide, in fact. Remove conditionals. It's about conditionals. It's a dedicated mutator. There is this mutator, and in fact, Nicolas has a mistake on this slide. There is this mutator which mutates mass operations. And the question is, which other operation will be affected by this mutator? Because we are analyzing bytecode. Increment. Because bytecode has no increment operation. It's going to be load const 1 and do plus. That's it. Now let's answer on your questions.
Other questions? Yeah.
Just a minute. I'd ask you to
Take the
speak
microphone,
with
please.
Microphone.
Oh, thanks. What is about reporting formats? Does Pit support any XML, JSON output files?
Okay. So basically, what you have for free is HTML. You can configure it, and in fact, I have a slide which configure it for XML. And if you use Sonar, but you're in the bad half of the room, you can upload your XML to Sonar, and there is a Pit plugin. So in your Sonar dashboard, you can also see your mutation testing, and you can break the build if your mutation testing is too low. And you've got also CSV, but there's no JSON.
You said that we still have to do other types of testing, such as performance testing. But did anybody try to implement some basic performance-related issues finding with Pit?
No,
Say you change something with mutators and your performance goes down, like that.
Sounds interesting. Question is a little bit broad.
I
Does
never
someone?
used it.
I did not. Nicolas did not, and we don't know the other guys which tried, so we are not aware. But maybe someone tried.
But thing is, you probably have a JUnit runner that makes you break the tests if it runs above a certain time. So probably you can do the same. You have to try. I have no better answer. I'm sorry.
You do have an API in Pit, so you can execute Pit out of your other Java application. We know that for GMH, for performance measurement, we have also API. We could combine those two.
Yeah, I mean, like you run some test with without mutation, and you profile the time. Then you mutate, you compare the time.
And the answer is yes, you do have an API, you could try it, but we are not aware of existing trials of this.
Hey, come on, give the girl the microphone. There are so few already.
Hello, thank you. I just wanted to ask your practical experience. Is it a good idea to mutate mocks? You know, when you do unit testing, you sometimes substitute your real parts of the system
but
mock you or something.
What you're doing for mocks, you're probably using some mocking framework, like, I don't know, quite popular nowadays, what I can't understand, but okay, it's another story. Power mock. So you probably use one of those. And Pit is not going to mutate your mocks, because Pit is going to look for what have been compiled for your main source code, not for the test code, not for the code of mocks, which is generated at runtime. So mocks are not mutated.
Pit wants to point out potential bugs in your code, so it will only mutate your own code.
And there is actually no reason to mutate mocks, because they are created in your tests. They are not your real code.
When I inject mocks, then I do like a kind of dependency. But you said that dependencies are mutated.
Yeah, dependency of your own code. Probably your class is not isolated. It depends on other class. It's object-oriented programming. So probably you have a class R that depends on your own class B and stuff.
It's not about runtime analysis of dependencies, who calls whom at which moment of time. It's more about static analysis of bytecode. My class uses another class. It's linked to it.
I want to ask about...
Ladies goes first,
Ladies
please.
first.
Ladies got the microphone.
I'm going to clarify one point about incremental analysis with Pit.
It's for you.
Am I right or not? You can perform an incremental analysis locally without pushing to your repository. Am I right?
You can do it locally. You can do it on CI server as well. As long as there is option, you specify where to save history. As long as you keep this history file, the next run is going to be incremental one. It's going to compare with this historical file and decide what was changed and what to run.
But if I made a pull from repository...
it's two different stuff. There are two different comparisons. One is about what he told you about incremental analysis, and what I told you is about SCM mutation coverage.
Oh, okay.
So there's two different, completely
But
different
this
stuff.
case of pull also valid one. So you have code base, you execute Pit, it's gonna keep this historical file. You're gonna do a pull, compile, and of course Pit will determine that everything what was pulled was changed. So indeed, after pull, there will be overhead to catch up with the state of master and so on.
Yeah, you are a girl, I'm French, I have to give you tokens.
How Pit handles infinite loop that happens because of condition change?
Good question.
Very good question, yeah.
I'm not going to come, but that's for you. Pit has... Okay.
I will do it.
Yeah. Pit has a timeout configurable one on execution of test. So if test is going to take too much, Pit is going to kill the test and decide that this mutation is actually killed by the test, because test runs into infinite loop. The behavior of test changed, mutant killed. If I'm not mistaken, this is even not an absolute timeout. It is relative to the to compute coverage, PIT needs to run your tests. So it executes your test without mutation. We can measure the time of tests, and then we can have some boundary, acceptable one, in order to decide is it infinite loop or whatever.
I think that the main question, how do you decide which mutators are good and not? So we're talking about the quality of our tests. So why do you think that this set of mutators is good for testing our...
I told you, apply every mutator you can add.
No, don't listen to this guy. Nicolas gave a pretty good basic set of mutators, which is boundaries, non-void calls, and so on. If you go on a PIT side, there is a doc which shows a list of mutators, and they also divide it on category stable and unstable. Stable ones, indeed, you could probably follow advice of Nicolas and enable them all and see what's going to happen.
Which is the default.
Which is probably the default behavior of PID, and that's why they call stable. But the list of unstable ones, they are unstable because they can produce a lot of identical mutations, so they're going to increase the time, but not really give you the benefit and the value. With those, be careful. And my personal recommendation would be or start with the default set, or start with 0 and enable one by one, think what is going to happen.
And my personal recommendation would be to enable all those tables, because, again, the smaller the scope, the smaller your safety net. And I really want to make sure that my testing code is of high quality, especially if you have a high code coverage and you trust it. Don't trust your code coverage.
We are running out of time.
Yeah,
so
sorry about that.
If you have some other questions,
you can catch us afterwards.
Yeah.
Thank you for your attention.
Thank you.